Of Darwin and champions of evolution and science to Sacramento's 13th annual Darwin Birthday Gala. I'm extending this welcome on behalf of the organizing committee, which you'll see listed on the back of your program. For starters, are we echoing here? No? For starters, did any of you see our ad in the Sacramento News and Review? If you would raise your hand so we can get a gist of it. Thank you, thank you. If you would just tell your friends that once we get rolling here, you're going to have a wonderful time. Tell them next year that'll probably be better than any ad we may get. I'm pleased to see you here today. I'm afraid that some of our fellow primates who are usually here are not here with us due to an unfortunate choice faced by the committee this year. Would it be Super Bowl Sunday or Valentine's? A decision that's made immediately after this event. Well, those folks have gravitated to their couches and TV sets to view the annual pigskin ritual. And according to yesterday's New York Times, scholars trace that ritual to a medieval activity in which a pigskin is kicked from village to village. And if you're lucky, you can get it up on the village's church roof. So it's medieval, huh? Well, here we are in the 21st century, at any rate. We know we're missing some folks, but we're going to be celebrating the 201st anniversary of someone who was and remains in the 21st century a scientific giant. Many scientists, in fact, think Darwin's theory of evolution through natural selection to be the most powerful scientific theory ever developed. Sacramentans, like us, are not alone in wanting to celebrate Darwin this week. The International Darwin Day Foundation lists our Carmichael event along with about 100 other Darwin celebrations that are happening around the U.S. and other parts of the world around now. Darwin's February birthday is coming up on Friday. The celebrations are taking place in colleges and communities, and it's not just secular people who are celebrating either. Many religious people, too, appreciate how important Darwin's theory has been to our understanding of the natural world. In fact, thanks to Evolution Weekend, which is next weekend, that was initiated by the 5-year-old Clergy Letter Project. People in 830 congregations are participating to elevate national dialogue on the topic of religion and evolution by annually celebrating Darwin's theory in their church services, synagogues, and temples to demonstrate that religion and modern science need not be at loggerheads. Not all religion is fundamentalist. At these events, secular, academic, or religious, we honor in some way Darwin's accomplishments and his contributions to human understanding. Each celebration takes a different route. There are lectures, there are sermons, music exhibitions, parties, film showings. In our event here in Carmichael, we try to make it into a birthday party of sorts. So you see happy birthday back there on the far wall. At a birthday party, normally one gives a gift to an honored person. Well, this time the reverse is the case. The honored person has given us the gift. It's a gift of understanding life, and part of the purpose of this setting is to show our gratitude for Darwin's proposition and to reaffirm it as a momentous idea. We call Sacramento's celebration a gala, an educational gala. And the main program is to educate about developments within evolutionary theory that continue to be made today, or about the social context of modern scientific enterprise. You also will find some educational material in the displays at the tables along the side. And if you haven't looked around, please visit those after the main presentation. Also, be sure to check out all the Darwin cartoons down the left-hand side. At this event, we promote and defend sound science education in curricula and public school programs. And this last point is what really spurs much of my own involvement in the Darwin Day for Sacramento. And thanks to the National Center for Science Education, we will have a drawing later at the education table. So if you haven't registered a ticket for the drawing over there, you can do that after the presentation while you know, the race is on for the birthday cake. It's open to anyone, not just teachers, but anybody who cares about having real science education that includes the teaching of evolutionary theory in the classroom, not creationism and not intelligent design. This day is a social event too, and we want to turn your brains on to science, but to have some fun. So before I turn this over to the MC, who will be directing us for the remainder of the afternoon, I would like to remind you that you are here to have some fun as well as to learn. And we're going to get rolling into a gala mood with a musical toast to Charlie. We're giving the tune a bit of a countrified twist. It's an easy melody, a nice beat, and so when we move along toward the end, I hope you will join us in singing the song. And this song is in honor of Charlie. By hand of the designer comes our Charlie, spins the world from here to Asia Minor. In between the platypus and perfect Aphrodite, Charlie come with opposing thumb to question the Almighty. Over the river and over the sea, through holy storm and thunder, steer a course for a brave new world of common sense and wonder. See the dancing president, the congressman and teacher, jump into the music of the wealthy Midwest preacher. Charlie, come with a brand new dance, get on the floor and follow. Find yourself a partner and we'll swing into tomorrow. Over the river and over the sea, through holy storm and thunder, steer a course for a brave new world of common sense and wonder. Stepping out, come join the worldwide party. Charge your glass and face the world. We'll drink a toast to Charlie. Over the river and over the sea, through holy storm and thunder, steer a course for a brand new world of common sense and wonder. Over the river and over the sea, through holy storm and thunder, steer a course for a brave new world of common sense and wonder. Hey, now you know the melody, you got the beat. Why not join in? You can sing this song. Over the river and over the sea, through holy storm and thunder, steer a course for a brave new world of common sense and wonder. Over the river and over the sea, through holy storm and thunder, steer a course for a brave new world of common sense and wonder. Last time, over the river and it is time to turn the program over to our MC for the afternoon, Liam McDaid, who is the Astronomy Coordinator at Sacramento City College. And it's all yours, Liam.
Try and leave this here for our speaker as well. Right here. How y'all doing today? Great. You know, I do a lot of lectures all over the world, and I like to say to people all the time when they come out to see us that I'm well aware that I'm competing with, you know, drinking, which you can do at any time. But on this particular day, of course, to see you all out here is really kind of remarkable and amazing. Nothing short of that at all. Wanted to have a couple thanks and acknowledgments for the volunteers who made this all happen. Although we clearly had some issues with the sound at the beginning, they've all been worked out now, and at least I hope you can hear me. Can you hear me in the back? Yeah. I'm Irish, I do not need amplification. Still, it's nice to have. So I want to thank all the volunteers that have worked so hard to make Darwin Day possible these last 13 years. And so if the people on the organizing committee could stand up right now and take a bow, I'd be really, really nice if they would. Come on, don't be shy. Come on. That includes Mynga. Yes. I also want to make an especially important note as well, because this thing's tilted, so everything keeps falling on me. To the food committee, who's done such an amazing job at creating such an impressive spread, particularly this year, as Darwin enters his 3rd century. The 201st birthday of Charlie Darwin is next weekend, in fact, which, again, raises the issue of why we're doing this on Super Bowl Sunday, but that's another question. So I also want to put a special recognition acknowledgement for Diana Ruth if she's here, because she is the one who has donated all the food for this event, and she should be recognized for her amazing generosity. Because, you know, anyone can give money, but to give food. As I keep telling those guys with the signs when I give them food and they look at me all annoyed and angry, I tell them food is much more important than money, because you can't drink food. Okay, I wanted to, our speaker this year, Dr. Marshall, is a man of great modesty apparently, because he wanted to have a relatively brief bio, so I won't spend all that much time on it. But I do want to say a couple things about him. Because, of course, if you come out here to see it, you want to know a little bit about what this person does. Clearly, you know what the talk is about, and I'll be moving the microphone and music stand out of the way for those of you on this side so you can see. Yeah. Speaker was kind enough to point that out. I didn't notice it. I was sitting right next to him. Dr. Andy Marshall is an ecologist, conservation biologist, and evolutionary anthropologist who works primarily on primates and tropical rainforests. Now, I'm assuming that would be primates in tropical rainforests, not primates and/or okay, just make sure clear. He's previously conducted research on several species of great apes in Asia and Africa. For the last 14 years, he has been primarily focused on research and conservation in Indonesia, where he's conducted more than 50 months of field work. Now, is that 50 months after you take out the time for paperwork and bureaucracy? Okay, that's serious, because that probably meant it was about 500 months altogether. Andy currently runs a long-term research project studying primate and tropical forest ecology in western Borneo, and recently co-edited a major 2-volume work entitled The Ecology of Papua. I'm assuming that's Papua New Guinea, right? Andy was trained at Harvard in biological anthropology, ecology, and botany, and is currently an assistant professor in the Department of Anthropology and the graduate group in ecology at UC Davis. So without any further ado, please welcome our speaker for Darwin Day 2010, Dr. Andy Marshall.
Thank you, Liam. Can you hear me okay at the back if I talk like this? Well, thank you all for coming. A couple of people have already made the point that I was going to make, which I realized that I was up against some serious competition today, which is that great American institution of the Super Bowl Sunday commercial festival. And I gather they also have some football that goes on during that time as well. And I appreciate you coming out despite that. It's my pleasure to talk to you today. So as Liam mentioned, I'm an evolutionary biologist, and as a scientist, I'm fundamentally, I believe that the kind of underpinning things that are related to science are very important. So the key ideas are that evidence is the most important thing, that any idea that we might have needs to be falsifiable. So in that sense, I'm a skeptic. But I'm also an idealist. I'm very interested in issues of conservation and the environment. And like many of the colleagues that I work with, what originally got me interested and involved in doing the work that I do was a desire to try and do something to contribute towards environmental issues. So today, I'm going to talk to you about an area of my own personal interest, which is tropical ecology and conservation, and focus specifically in the part of the world where I work, which is Borneo. And by doing that, I'd like to share with you some examples that demonstrate, I hope, what I've indicated in my title here, how conservation depends on evolutionary biology. So I mentioned that I work in tropical forests, and most people have heard of tropical forests, and by now most people have some sense that they're important, at least for some reasons. Tropical forests have long been a topic of substantial interest, and I've got an old carving up here from 1840s that depicts the Atlantic coast of Brazil. And as you can see, there's people standing in a ring all around that tree. So this is a really fantastic depiction of this. There aren't trees that are actually that big. I'm sorry to tell you. I wish there were, but that's sort of bigger than the physiological limitations that plants can actually overcome. So there are sort of fantastic descriptions of the rainforest. But not all of the misunderstanding of rainforests is related to just sensationalism. In fact, serious scientists made serious mistakes about the rainforest from pretty early on. So here's just a simple example of this. This is a picture. It's in black and white to indicate that it was some time ago. And you can see here that this is a tree exhibiting a trait which is known as caulifery, which is simply fruiting directly out of the stem of the tree, right out of the trunk. Now, all of the botanists that were interested in these kinds of issues and who were identifying the samples that were brought back from these remote tropical forests had never seen this. There aren't any trees in Europe that fruit like this, so they actually assumed that this was a parasitic plant that was growing on this tree, and they gave it its own scientific name. Of course, now we know that that's not what happened, and this is not particularly common, but this is just two examples of that same kind of phenomenon in the tropical forest where I work. So this is growing directly out of a tree. So one of the things that really interests me about tropical forests is just all of the amazing things that you can see there. It's just absolutely full of incredible things. And evolutionary biologists all have their own favorite examples that they can give, and here's one of mine. This is one of the perhaps 20,000 species of orchids that grow on the island of New Guinea. You can see it here. Now, sitting in the middle there is what looks like a spider, but it's not a spider. It's the stamen and pistil and the central reproductive parts of the flower that have been modified by natural selection to look like a spider. So this is a really remarkable example of convergence. Now, we don't really have any idea what this is for, and I was on an expedition to Papua about 3 years ago and spent what turned out to be a very boring afternoon watching one of these things. And absolutely nothing happened, so I'm sorry to report I can't tell you anything more than we knew before. I think the most sort of reasonable hypothesis is that maybe spiders come up to this thing and either because they want to fight it or more likely mate it, they get on top of it and they probably get pollen on themselves and they go on to the next flower and they serve as pollinators. So we're used to bees pollinating, and perhaps this is a spider pollinated plant. Here's another example. This is Wallace's flying frog. And at this point, I do want to acknowledge a good friend of mine, Tim Lehman, who's a National Geographic photographer, and who took many of the excellent pictures that I'll show you today. All the ones that look like they're really professional and well done are by Tim, and those that don't, generally I took. So you can tell the difference. So this is one of Tim's amazing pictures. And I mentioned this is called Wallace's flying frog, and the reason it's called that is because it glides like a tree squirrel might. It has massive webbed feet, as you can see in the picture here, and these large flaps of skin in between its digits are actually sufficient to let it float through the air. So you don't see these very often in the forest, but during rainstorms, these males will all come into a certain area and compete with one another, and they actually jump out of trees and float like this. Right? They just sort of float down on their feet. Really amazing. So here's just one other example of the kind of weird and wonderful things to be found in the rainforest. This is a stick insect, and as you can see, if you can see the scale there, this is about 1.5 feet long. And we saw this walking in front of the camp where I work in Borneo. And I sort of assumed that these things are all over the forest, and it was only when it happened to be out of where it's normally found that we got a chance to see it. So I could spend the entire afternoon showing you pictures like this, amazing pictures of diversity, of incredible critters, each of them more amazing than the last. But the basic point is that tropical forests house an awful lot of biodiversity. There are many, many species that are found there. That's one of the things that we find so interesting. The reason I put this beetle picture up here is in part because they're just incredible, and the range of colors here is just remarkable. But it also gives me an excuse to pass on to you what is one of the more humorous quotes from my perspective made by an evolutionary biologist. Now, to give the sort of context for this, I do need to let you know that beetles are actually one of the most speciose groups in the whole world. There are between 250 and 350,000 species of beetles. That's maybe 20% of the about 1.5 million species of plants and animals in the entire world. So these are incredibly diverse. So this is a picture of J.B.S. Haldane, who was a very famous British evolutionary geneticist. He was very involved in what's known as the modern synthesis, which is where geneticists and evolutionary biologists brought together Darwin's theory with sort of more modern developments in genetics to sort of create a more synthetic and a more comprehensive theory. And he was really quite famous and was involved in all kinds of issues in evolutionary biology for many decades. And towards the end of his very illustrious career, a British preacher came to him and said, "So after these many, many years of research, what insight has it given you into the mind of the Creator?" And his response to that was reportedly, he has an inordinate fondness for beetles. So forests are amazing for their biodiversity, but they're also important for other reasons as well. One sort of really important reason that perhaps we might forget about just sitting where we are today is that lots of people actually live in them. Many people depend on them. Here's just a couple of examples. On the left, that's an Asmat man from Papua, where I've done a little bit of work. That's a bridge on the right built by the Dayaks, who are the Aboriginal forest people in Borneo. And here's just a couple of other examples of those Dayaks. So these local people and many other groups in the Amazon and Africa and many other places depend on the forest. It's not simply a place to film interesting nature shows and show you amazing pictures from. Right? It's where they get their food, it's where they collect various things to build their homes, generally to make their clothes. The fact that the forests still stand is the reason that they have fresh water, and that sort of thing. So they're important for local people. But it turns out that we need them too. Now there are many different estimates of this, but sort of the most consistent one that I could find was that perhaps 120 prescription drugs that are used in the world today came solely from rainforest plants. That's perhaps 25% of the drugs that we use today. According to the U.S. National Cancer Institute, more than 2/3 of the medicines that are used to treat cancer come directly from tropical forests plants. There are many different examples of this. One of my favorites is something that was synthesized from a now extinct species of periwinkle that grew in Madagascar. It looked a lot like this one I've got up here. It's disappeared now because of deforestation in Madagascar. But the compounds that they have isolated from this particular species has raised the survival rates of children with leukemia from 20% to 80%. So there's really useful stuff to be had in the tropical forest. It's also important in other ways as well, and one really important way that's got a lot of attention in the press more recently is its role in global climate change, and specifically in mitigating some of the effects of global climate change. So we all learned in grade school, I hope, that plants take in sunlight and CO2 in order to grow. So vast swaths of forest are particularly important to basically scrub the air that we breathe. But the second reason they're particularly important is that they sequester an awful lot of carbon. We know carbon and various forms of carbon is one of the key greenhouse gases that underpins global climate change. Now, you can see, or perhaps you can't, that was the best version that I could find on the right, that bar graph there. And I guess it's not really clear enough, but on the left it shows the global distribution of peat bogs. Now, those of you who've thought about peat bogs at all probably think about them in the context of single malt Scotch and the fact that they're in Scotland and other places in the world. But in fact, there are substantial swaths of peat forests in the tropics as well, including on Borneo. And in some of these places, the peat can be 20, 25 meters deep. This is incredibly deep. And one of the things about peat is that it holds an awful lot of carbon, which is why people in some places still use peat as fuel. So the problem is, when forests get degraded, particularly peat forests get degraded, all of that carbon that is sequestered in the peat is released into the atmosphere. And here's just a single example. The island of Borneo that I'm going to be spending most of today talking about, that's the picture down there on the left, had some massive fires in between 1997 and 1998. It was a period of about 4 to 5 months where the forests were burning. This happens every year during the dry season, but this was a particularly bad time because it was an El Nino year. Here you can just see a map. This is actually a more recent one. This is from this past summer that shows more than 2,000 fires which were large enough to be actually seen by satellites from space. So these are really large fires that are deliberately set by people to clear their fields, but they don't generally take care of the fires and they can go into the forests and burn the peat. During this particularly bad fire in 97 and 98, there were 2.5 billion tons of carbon dioxide released from this burning of the peat. Now that number is huge and probably doesn't mean much to you, but that's the same as the greenhouse gas emission from all of Europe for a whole year. That's in one fire on the island of Borneo. So there's really important things. I mean, we could, and we can, and we do, and we should argue about miles per gallon issues related to cars and that kind of thing, but we could work really hard on those issues, but then let Borneo burn for one summer, and any good that we might have done will be completely offset that way. And believe it or not, it's probably easier to protect the forests in Borneo than it is to try and get miles per gallon things through US Congress. So I would suggest that this might be a more efficient way to do it as well. Unfortunately, as you've no doubt heard, tropical forests are disappearing. Now, there are all kinds of different statistics about this that I could tell you that might really depress you, and I'm not going to go into details about that. Suffice it to say, you've probably heard about it, and it's really bad. It turns out that it's actually not that easy to measure rates of tropical forest loss. We do it using satellites, but the people that do this kind of GIS analysis tell me that it's as much an art as a science, and you take an awful lot of data, and it's not always easy to convert that into real estimates of the rate at which forests are being lost. So there's probably quite a bit of uncertainty about this. But here's a kind of typical map that you might see that shows forest gain, which is the dark green, forest loss, which is the light green, and the areas with no change in red. Now the key thing here is that the areas that we're still losing forests around the world are the areas around the equator. These are the areas that house the most biodiversity, where people are directly dependent on the forest for their livelihoods. So I won't depress you with more facts and figures about how dangerous or how bad the situation is for tropical forests, but trust me, the news isn't that great. But today I want to focus on one relatively small part of the world, which is the island of Borneo, depicted up here. And it's small, I say, but it is the third largest island in the world, and it still has pretty large swaths of tropical forest left. In fact, after the Amazon and the Congo Basin and the island of New Guinea, this is the largest area of tropical forest left in the world. So there's still lots of important forest to be found there. Now, as a large island with lots of tropical forest remaining on it, it has a lot of those really interesting aspects of biodiversity that I mentioned before. Here's just a couple of examples of that. On the left, that's one of the many species of pitcher plants that are found in Borneo. On the right, that's Rafflesia, which is a plant species that produces the largest flowers in the world. They're perhaps a yard across. These are massive flowers. And more disgustingly, they actually disperse their pollen through attracting flies, so they smell exactly like rotting meat. So there's lots of biodiversity on Borneo. There are many different ways to measure this. World Wildlife Fund, for example, has reported that 361 new species have been reported there just in the last 10 years. So it's still, we're still finding new things here. Well, like everywhere, the forests on Borneo are disappearing as well. I first arrived in Borneo in 1996, which is the year that I graduated from college. And this shows areas of forest that have been lost just since that time when I arrived there. No, I'm not taking credit for that. But we've seen an awful lot of forest has been lost here. And going there and seeing this and seeing the changes that have occurred just over the relatively short period of time that I've been going back there, I'm prompted, as many of my colleagues are, to ask, what can I actually do to contribute? Now, on one level, the rainforest probably doesn't need more evolutionary biologists. They probably need more fundraisers and activists and lawyers, and I would argue probably armed guards as well. But of course, we'll contribute best by doing the things that we're actually good at. So I was trying to think about ways that I might be able to try to make my research actually important, or at least beneficial for the tropical forest. Well, we know that just by virtue of doing research in tropical forests, we can have some positive effect, just by virtue of our being there. Having foreign scientists or scientists from the countries in which these forests grow on site just simply raises awareness. Usually we have national park staff with us that can monitor things, and it can just step up enforcement. It's also quite important for training local people, the next generation of people who do conservation in these forests. So there are reasons that we might use to justify what we do, and indeed we often do. But many of us, myself included, would like the results of our scientific studies actually to be more directly applicable to conservation. We might be useful just by virtue of being there, but then it wouldn't matter what we did when we were there. We could just be sitting there and listening to our iPods. We really hope that what we do actually makes a difference. Now, to be completely honest, I must admit that I'm still not satisfied with the extent to which the work that I do, or scientists more broadly, really does directly contribute to conservation. But I do want to talk about 3 different examples here of studies that I have been involved in that I think do contribute meaningfully to conservation in Borneo. So this is a scientific, but it's a highly personal view of things. I'm mentioning studies that I've been directly involved in myself, but the implication is, or at least my assertion is, that some of the things that we're finding in Borneo are applicable more broadly to tropical forests in other parts of the world. So why is this relevant to Darwin Day? After all, Darwin himself was not a conservationist, at least not in the sense that we would use the word today. Like everybody else at that time who was doing biology, he did an awful lot of collecting, which is a euphemism for shooting animals, of course, and bringing them back to museums. So we wouldn't really hold him up as a sort of arch conservationist. But it turns out that some of these scientific ideas that I'm mentioning, or I will mention today, directly stem from his initial arguments. Right? Many of the principles that he mentioned are still informing what we do to this day. And I'm going to structure my presentation in the form of basically answers to 3 really simple questions. The first is, as conservation biologists, as scientists who are interested in preserving tropical forests, should we focus solely on working in forests that are pristine, things that have not yet been touched? Then I'm going to ask a question, and again a very simple question. Are all species that live in tropical forests affected equally by some of the negative things that go on in tropical forests? And finally, I'll ask, are all forests created equal? Now, we already know that looking across the globe, that forests along the equator have much higher biodiversity, for example, and if we're interested in looking for medicinal plants that might cure cancer, perhaps AIDS, tropical forests are the places that we want to look, because there's just a lot more chances of finding something there, because there's higher diversity. But I'm actually focusing on within Borneo today. Is there variation among forest types in Borneo that is relevant for us as conservationists? So starting on that first question, should we focus solely on pristine forests? I'm going to mention to you a little bit about a particular study that I was involved in that focused on orangutans. which are large great apes, the only great apes found in Asia. Darwin himself actually feared for the future of the great apes. In his second book, which is not as famous as On the Origin of Species, but The Descent of Man and Selection in Relation to Sex, he said the following quote: "At some future period, not very distant as measured by centuries, the anthropomorphous apes will no doubt be exterminated." So Darwin feared for the future of these critters even back then, although now most of us that have worked on these issues would argue that the concern on the level of centuries was probably a little bit optimistic. In fact, those of us that work on great apes and conservation think that it's actually possible that the Sumatran orangutan could go extinct within my lifetime. So the problem for orangutans is that they're very thin on the ground. Right? They live at very low population densities. And they're also cursed by a number of other sort of basic factors about their biology. Turns out they're the most slowly reproducing mammal in the world. They have, on average, 9 years between successive births. So a single female doesn't produce very many offspring in her lifespan. So populations grow very, very slowly. Of course, if you are very thin on the ground, you need a relatively large area in order to have a big enough population that has some chance of long-term viability. And I'm going to talk about that again in a minute. But unfortunately, along with all the other species that focus or live in tropical forests on Borneo, they've lost 80% of their habitat just in the last 20 years. Here's a time series analysis from 1950 up to 2005, which is the last panel here, which is actual data. The 2010 was a projection that was done in 2008, and I'm sorry to say that it's actually worse than they projected up here. So the remaining patches of forest on Borneo are shrinking, and they're also becoming more and more fragmented from one another. Much of this fragmentation, much of this forest loss was originally due to just logging, but now the biggest threat by far is the palm oil industry. And actually this is one of those great examples, or tragic examples really, of unforeseen consequences. There was a big push for biofuels, and oil palm, or the oil that's produced from these plants, actually is an important biofuel, and it was heavily pushed. In the process of doing this, they've slated for clearing, and in fact already cleared, much of the remaining lowland forest on the island of Borneo in the name of conservation, in the name of biofuels. So here's another map of the island of Borneo. And what I've done there in that square, that's a square that represents an area of 250 square kilometers. Now I picked that number because as conservation biologists, we have a kind of rule of thumb that you need a population of at least 500 individuals in order to have some kind of hope of long-term viability. And average densities of orangutans are about 2 per square kilometer, so that's about how big of an area you need to protect a population, a minimum population that we think would be big enough to survive, say, for the next 1,000 years. On this map here, you can see in that hatched areas, those are the protected areas left in Borneo. And you can see that very few of those areas are actually that big. And in fact, the two largest swaths that you can see in the middle there are forests on top of mountains, which I'll return to in the last part of my talk. So most of the protected areas are simply not big enough. We also know now that only about 25% of the orangutans that remain live inside national parks, live inside areas with any kind of formal protection. And a number of us have argued, using just kind of very simple mathematical models and population projections, that even if we protect every single orangutan that is still living in a national park on Borneo, which none of us believe for a moment we'll be able to do, that's still not going to be enough to protect the orangutans in perpetuity. So, if orangutans could survive and reproduce in some of these forests that have at least been marginally degraded by logging, it might dramatically increase the area of forest that we have to work with. So that raises a really simple question. Can orangutans live and reproduce in forests that have been logged? Now, there's a large body of work by lots of people going back since before I was born, looking at the effects of logging on Bornean mammals. An awful lot of this has focused on orangutans. But the problem is the results of this are really quite equivocal. Some studies report higher population densities in logged forests, some report lower densities, others report no changes. And lest you think this is different groups of people with different agendas, the authors on these papers are kind of the same group of about 15 of us that are reshuffled and publish studies on different areas. I've published on each of them. Each of those papers I'm involved in. So it's not simply people with different perspectives. The data that we get from different areas show us different things. Well, there are peculiarities and caveats that we might mention about any one of these particular studies. But I was always struck by the fact that perhaps one of the other reasons why the studies weren't giving us really clear results was that multiple factors were involved. A simple study that just compared a single log forest and a single unlogged forest could give different kinds of results for lots of different sorts of reasons. For example, we know that hunting tends to correlate with logging. Areas where selective loggers go in, they tend to hunt in order to feed themselves. So we really want to be able to tease these two things apart to figure out what's the real risk. So in collaboration with the Nature Conservancy, which many of you may know is a large environmental NGO, which is very active here in the US, but also internationally, I designed a project to try and get at this question. And we used this province in Borneo, East Kalimantan, because we thought it was a really good test case for a number of reasons. It's a large landscape, as you can see up there. And it's kind of now a mosaic of pristine forests and forests that have been logged to different degrees of severity. And hunting occurs in some places and doesn't occur in others. So we thought it would be a really nice test case if we could actually go about sampling in a statistically defensible way. So just a few words about the basic methods that we used in this study. Over a period of about 3 years, we put in a fairly large number of transects, which are just straight pieces of walks that you'll do through the forest, and you record certain things as you walk through the forest. And we spread these out at a large number of different sites. So this sort of sampling broadly across the landscape is different than people had done before. And along these transects, we measured not the abundance of orangutans, because they're really thin on the ground, and it turns out you have to watch or go through the forest for many, many, many days before you often will see an orangutan. So if you're really interested in trying to assess how many there are, it's better if you can have something that might be actually correlated with orangutan densities. And what we landed upon were the nests that orangutans make. Now, orangutans will make these nests up in the canopy every night. They fold a bunch of sticks together and interweave them and make a sleeping platform, which they then sleep in, and then they make a fresh one every night. So if you can go through the forest and actually count these nests and appropriately calibrate that based on the rate at which orangutans make nests and how quickly they decay, you can get a pretty good index of how many orangutans are in a particular kind of forest. So we did that, and we did all kinds of other measurements looking at the importance of logging there, whether hunting occurred or not. And we also did lots of botanical measures to see were there differences between these forests in terms of their basic quality. Oh, and I should also mention, the Nature Conservancy teams did really extensive surveys in all of the villages in these areas to figure out hunting behavior. Were people hunting orangutans, and if they were, at what intensity? So I don't know how clear this is. This is a map of that area. The basic point, though, is that these sites are pretty well distributed. We worked in a pretty large proportion of this entire region, and just to blow it up here, you can see each of those different areas or places that we sampled. Right? The red areas are places where we slept for the night. The green flags are places where we collected data. Right? It's not important exactly where they all are, but the point is that we spent quite a lot of time out there doing this and collected quite a lot of data, certainly more than had ever been done before. Well, I mentioned before that it's entirely plausible that multiple factors are actually responsible for the patterns that we see, and that's actually why we don't see a clear pattern in the previous studies that had come before. So I needed to tease these apart using a statistical method known as multivariate analysis, which is Just a simple way to describe using a number of different variables in the same model and looking at the importance of any one of them while you hold the effects of the other ones constant. So you can really tease apart different kinds of effects by doing this. And when I looked at a number of different variables in doing this analysis, I found that a very clear predictor of the abundance of orangutans in a particular piece of forest was simply how close was that forest to the nearest village where individuals hunted orangutans. A really simple kind of spatial measure that we inferred or assumed was very closely related to probably the intensity with which they were hunted. In these models that included lots of other variables, once you include this variable, other things that we might assume would have been important, like the quality of the forest, whether it had been logged or not, actually were statistically insignificant. The really important thing was hunting. And I would argue that the reason that many of us had found in earlier studies that logging was important was because when logging goes on, hunting tends to go on. And it's only when we had this large sample of sites using a sort of really scientific study design that we could actually tease these two apart. So hunting seemed to be the real threat. You just see, this is a policeman who's confiscated an orangutan skull that's been carved by the Dayaks, the local people there. These are highly prized. So the conclusion of this, it was actually a very simple study, it just took an awful lot of time to do, was that orangutans are extremely susceptible to population declines due to hunting. But once you control for that, they're really quite tolerant of logging. Now these results can actually be confirmed as well by basic population simulations, and those of us who do conservation biology frequently do mathematical models to try and predict how populations might respond to future insults. So you basically build a mathematical model using the best data you have from the wild about how often they reproduce, their lifespans, that sort of thing. And then you can plot the populations using that simple demographic data. And when you have a good model that seems to reflect the way a population should work, you can throw various insults at it and see how it affects them. So here's what we did in this particular study. This just plots the probability that orangutans will persist, or actually it plots the size of the population over time under different hunting rates. So the green line is in that model, it includes no hunting whatsoever. The blue line is if you hunt 1% per year, that's the population drop. And as soon as you go to 2% per year, the populations go extinct in about 500 years. Darwin noted in some of his early work how even very slow reproductive rates could quickly make populations huge. He worried about the fact that his example was elephants. Elephants reproduce incredibly slowly, but if they were unchecked, we'd pretty soon be knee-deep in elephants. That's the reason that you're supposed to invest early, right, with compounding growth. Right? Even if the increases are small, if you give populations enough time, they grow. Well, this is kind of the doomsday reverse example of that. If you take off 1-2% of the population, it might take a while, but the population certainly goes extinct. Now, none of us, I think, would argue that we were capable of measuring the difference between 1 or 2 or 3% hunting in the wild. Right? Simply too difficult to do. So we really can't allow any hunting whatsoever if we want to avoid their extinction. Now, of course, this is not the way it's going at the moment. Some hunting is done for food, but most hunting is done for the pet trade, where mothers are shot and killed, and the infants are taken to be sold to people who want to keep them as pets, who then love having them for a year or 2 years until they grow up and they're wild animals in the house. And of course, they tend not to survive as well. But hundreds of infants come into these centers every year from being hunted for the pet trade. Now that seems bad enough as it is, but we actually know that for every one of those infants that makes it, maybe 4 other infants die in transit or in the process of being caught in the wild. So every one infant you see in a transit center represents maybe 4 or 5 dead infants and 4 or 5 dead mothers. This is way, way more than 3% per year. I've played with some numbers, it looks more like maybe 10% of the population per year. You can't really sustain anything by taking 10% of it each year for very long. Okay, so I mentioned that it was a pretty simple study, but I think it has some important applications for conservation. I want to mention a few of them now. The first, and the one that I think is really important, is that light to moderate logging is not incompatible with orangutan conservation. Logged forests retain high conservation value. Now, I'm not going to argue that we shouldn't try and protect pristine forests. There are many species that can't survive in logged forests. But orangutans are one of the most threatened, and it turns out that they actually can subsist in these forests that people have extracted the really valuable timber from. This implies that if we ignore doing conservation except in the few areas left that are pristine, we're going to miss important opportunities to still do real conservation work. Now, although agricultural encroachment and other kinds of land clearing clearly have negative effects on orangutans, my analysis also showed that simply being close to human villages didn't predispose orangutan populations to decline. As long as those villages didn't hunt, there was no problems whatsoever. So this suggests that some of these integrated conservation and development projects, which are in vogue at the moment, like allowing local people to collect non-timber forest products, that kind of thing, is entirely consistent with the conservation of orangutans, at least in this area. And this is pretty much clear, I think, from what I've already said, but our conservation efforts really should focus on trying to prevent hunting. Right? 1–2% alone can make a huge difference. We shouldn't be worried about people taking out the odd tree. Right? What we should be worried about is people taking out the odd orangutan. And I will note that this is actually a far more realistic goal in Borneo than it would be for, say, in the Congo Basin, where bushmeat is really a crucial food resource for many of the people there. In this area, people will eat orangutans if they can get them, but they certainly don't subsist on them. So I think there's a realistic expectation that we could actually achieve this. As a conservation practitioner in Indonesia, I frequently run into the attitude with politicians or other managers that as soon as a forest has been logged just a little bit, it's done. Just strike it off the map. And if you do that, this area that still retains really high conservation value, we won't pay any more attention to, and then it will be logged subsequently and logged again, and it will burn, and then it really will be useless for conservation. So one of the things I've been trying to do over the last few years is really highlight the importance of these areas that have only been moderately degraded. We really still can do conservation in most of the forests. Now, I mentioned before that most of the protected areas in Borneo are not big enough to house populations that are big enough to have long-term sustainability. So this implies that if we included a buffer zone around a national park that was maybe forest that local people could utilize, that could take out timber species, sell them, make a living from them, but not severely degrade that forest, that would substantially increase the amount of area that we had for that particular population. And adding that forest, even though it's not pristine forest, might bump the size up large enough that the population that would have been not viable in that small pristine area is all of a sudden viable because you've added additional individuals. So this suggests that having a kind of more landscape perspective on conservation could really improve our chances of protecting these species. So the answer to my first really simple question was we should not focus solely on pristine forests. Again, not to suggest that forests that have been untouched aren't important for a lot of species, but we will miss important opportunities if we only focus on those particular areas. And in fact, on a practical level, if we're interested in only doing conservation in pristine forests in Indonesia, we may as well go home because there's not going to be much work left to do. So the study that I just talked about showed that orangutans actually can do surprisingly well and better than anyone previously thought in forests that were moderately logged. So a reasonable follow-up question that you might have is, well, to what extent does this measurement or this characteristic extend more broadly to other species? In other words, are all tropical forest species affected in the same way when we log forests? Well, Darwin was very aware of the importance of long time spans. Most taxa evolve, most species evolve over very long periods of time, and it's those long durations of time that are necessary to accrue the gradual change that Darwin thought was really important. So this is a quote from Darwin in a letter that he wrote to Asa Gray in 1857. He said, "I cannot doubt that during millions of generations, individuals of a species will be occasionally born with some slight variation, profitable to some part of their economy. Such individuals will have a better chance of surviving and of propagating their new and slightly different structures, and the modification may be slowly increased by the cumulative action of natural selection to any profitable extent." Long-term change is really important. To Darwin, these long-term scales are really, really important. If you can't read that at the back, it says, "Very gradual change, we can believe it." Well, it turns out that these long evolutionary timescales that Darwin was really obsessed with are even important today to very pressing current-day environmental issues. And so I'm going to talk very briefly about a study that I did with a number of collaborators to try and get at that question that I just posed. Are species all affected in the same way? And we basically did this study by compiling our own observations from the field, but we also trolled the literature and took every published study we could find that had ever been published on a Bornean mammal species. And it turned out that we ended up getting data on 41 different species, which was pretty good. We were surprised. And the details of this, I don't expect you to read them, but based on quantitative criteria, we identified or we characterized each of these species as either tolerant, intolerant, or neutral to logging. And that measure was simply related to changes in their population density before and after logging. So species whose populations crashed after you log a forest were classified as intolerant. Species that actually increased in densities after logging were tolerant, and the ones in the middle were neutral. So the answer to that question I just posed was yes, species actually differ quite a lot in their responses to habitat degradation. And the results of this literature search showed that species, these three characteristics, the different species in Borneo were pretty well distributed among these three different groups. So some species really were totally intolerant of logging. You do kind of any logging at all, you lose them. And examples of that included the three pictures I've got up there: the sun bear, the gibbon, and the yellow barking deer. A number of species were neutral, including orangutans, as I've just mentioned now in that previous study. Also the binturong, which is related to a weasel or a civet. We don't have anything like that here, but it's just another species that lives out there, and bearded pigs. And then there are a number of species that actually do pretty well and even better in logged forest than they would in unlogged forests. And these tend to be species like elephants or the banteng, which is a large, basically wild version of a water buffalo, that like to feed on really new vegetation that tends to grow up once you log a forest. So not all species are affected in the same way at all. This is a full list. I know you can't read that. That's a picture of the evolutionary relationship of many different mammal groups. It includes primates, squirrels, rodents, many other groups. And the thing I just want you to take from that picture is that the susceptibility to logging is dispersed pretty evenly across evolutionary space. It's not that some radiation, some groups of animals are very susceptible and others aren't. It's really quite dispersed. So the answer to that question I just proposed is, well, no. Species are not all affected the same way. But a more interesting question from a conservation point of view and from a scientific point of view is, well, what makes some species susceptible and other species not? In other words, what predicts sensitivity to logging? Now here's another complicated table, again, that I don't expect you to be able to read from back there. But it lists a number of different variables that we considered in this model. Right? We tried to think about what might actually predict what makes a species decline in logged forests. And we included any variable that anyone had ever proposed might be important. So all the things you might think about: the size of their body, what they ate, their reproductive rates, their distribution in space, that sort of thing. And we threw all of these different parameters, all of these different aspects about the species, into another one of these big multivariate models and saw what came out. So to summarize the general patterns we found, I'm going to talk about just classifying them but in these two groups, tolerant and intolerant species. The neutral species were somewhere in between. Well, our first two results were not all that surprising. Species that were intolerant were species that strictly dwelled in the canopy. Not surprising at all. If you cut down trees, species that use the canopy don't respond to that very well, whereas species that can use lots of different layers of the forest do pretty well. No surprise there, and other people have found that as well. Also, the more specialized a species was in terms of their diet, the more affected they were by logging as well. So things like strict carnivores did much worse in general than species that can eat leaves. Again, makes perfect sense. But we actually found a trait that really surprised us and that is related to the topics I've been mentioning. The age of the species actually was a significant predictor, and in fact, once you put all of these things into a single model, it was the only predictor that came out as important. Specifically, I mean, is how long ago did that species evolve? So we can divide the two groups that we found into kind of two basic groups that I'm going to do for you here. There were those species that evolved during the Miocene or the early Pliocene. These are species that evolved 4 to 13 million years ago. Now, as we know, climate change has been going on immemorial. The problems with climate change today are not that the climate is changing, it's the rate at which it's changing. And we know that during this period in time, between 4 and 13 million years ago, these were periods of relative warmth and relative climatic stability on the Earth. Forests were fairly stable, they were fairly closed canopy, and I would argue that during this period, perhaps you had forests that looked more or less like currently unlogged, pristine tropical forests look like. So species that evolved during this period were those species that were intolerant of logging in the modern day. The second group of species during this time, we know that forests were expanding and shrinking and expanding and shrinking, and probably the canopy of forests were fairly discontinuous. And I would argue that perhaps it looked kind of like what tropical forests look like today when you log them. And of course, these were the species that were tolerant of logging. So this suggests the intriguing possibility that something that happened at a time when a species originated 5, 10, 15 million years ago affect today how it will respond to whether we log the forest or not, the anticipated effects of global climate change. We were really shocked. And we think it has two kind of important conservation implications. The one is that most species are pretty tolerant of well-managed logging, as I mentioned with the orangutans earlier. But the few species that are really intolerant, are really susceptible to population declines in logged forests, are also those species that are threatened with extinction globally. In other words, there's a close correspondence between local and global threats. The second kind of interesting thing that I think comes out of this is that simply knowing the evolutionary history of a species might allow us to predict how it will respond in the future to ways in which we might alter its environment. Now, as you might imagine, it takes an awful lot of time to go out and do a detailed behavioral study of each of the species of tree shrew that we're interested in. Not to mention the fact that it would be insufferably boring from my perspective. But it's now really, really easy to get genetic samples. All you have to do is catch a single individual, get a blood sample, and you can quickly characterize a species phylogenetically based on its evolutionary relatedness. And this simple method might actually enable us to target specific species that we think, purely on the basis of their evolutionary history, might be particularly susceptible to risk. And those can be the species that we give really special targeted conservation attention to. So the answer to my second question was, forest species are affected differently, and that can help us to actually manage and protect them. So the final question that I want to pose to you and then answer is related to, well, as I stated up there, it's are all forests created equal? Darwin was really aware that variation in space was really important. He talked about plants producing tens of thousands of seeds and them scattering across the entire landscape, and many of those seeds might land in habitats or environments that could not support that particular species. So he was very well aware of variation in space affecting species' ability to persist. And I was interested in thinking about, well, are these kinds of things going on within tropical forests? We tend to think of tropical forests as kind of monolithic, really diverse, but all kind of the same. But those of us who work in them know there is actually quite a lot of variation. And I was interested in knowing, does this variation affect the species that live there? Kind of in the same way that Darwin was talking about those plants. Can species really propagate across the entire landscape and do okay? Or are there only a subset of the potential areas that they can thrive in? So in order to talk about this, I have to just briefly mention a very large and interesting kind of theoretical area in conservation biology and ecology, which are known as source sink population dynamics. Now this is a sort of fun, theoretical, and quite mathematical area. But I think the key elements of this, we don't need to think about the math at all. They can be very, very simply characterized. All we really need to do is to assume, and actually we know this is true, that space is variable. Forests are not the same across space. Then we just need to assume that the reproductive output of species varies based on the forest that they live in. In other words, forests differ in their quality, and the different qualities affect the reproductive output of the species that live in them. We've measured this for lots of species, we know it happens. In some of these forests, there'll be high quality, there'll be lots of food, and these species reproduce at rates higher than replacement. They have positive growth rates, more individuals are born there than can survive. Right? Those populations are growing. There are other habitats that actually are of such low quality that fewer individuals are born there each generation than can sustain a population. Populations shrink. Right? So the population areas, or these parts of the landscape in which populations can get bigger, are known as sources, and those in which the populations will decline are known as sinks. Now, if a sink forest just was set off on its own somewhere, of course, we know that whatever species that live there would decline to extinction. But if you are in a landscape, as many tropical landscapes are, that are kind of a mosaic of these different forest types, you can actually have individuals flowing out of these source forests into the sink forests, so that the populations can actually persist in these sink forests, even though those forests are not of high enough quality to actually sustain them. So I was interested in seeing whether these kinds of dynamics were going on with my study population in Borneo. So as it's been mentioned, I've worked in Borneo for 14 years, and I've been working at a number of places, but I keep going back to this particular place called Gunung Palung National Park, which is in western Borneo. And I want to just give you just a very brief introduction to that. This is a different picture. This is when the space shuttle flew over and took radar data of the island of Borneo, and this gives you a nice depiction of the kind of elevational gradient within that national park. So the reason that I chose to work there is there's a really wide variety of different forest types that are found within this single national park. I don't know how clearly you can see it, but on this mountain, on the front there, you can see a series of blue lines kind of spidered all over there. That's our trail system. So we have research trails that basically penetrate many different kinds of forest there. And I'm really interested in kind of basic ecological questions about how the forest, how the environment affects primate populations. So this is a perfect place for me to do my studies because I can actually gather data on the same population living across a wide range of different ecological conditions. And unlike comparing areas that are separated, one national park in one place and one national park somewhere else, because it's a one contiguous area, I can kind of control for many of the things that might otherwise confound these analyses. Maybe there are predators at one place and not predators somewhere else, or there are special diseases, etc. But this is a contiguous area, they're all connected, so we can be fairly certain that most of the things that we're worried that might bias this analysis are consistent. So this is just a different map of that trail system that I work in, and the different colors are the different forest types, and I work in 7 very different kinds of forest. And it may be a little difficult for you to picture how can tropical forests actually vary, and maybe these are just really minute differences that you need to know lots about botany to distinguish, but they're actually really not difficult to distinguish at all. I could sit and give you a kind of 5-minute précis of what these different forest types are like, and blindfold you and drop you in Borneo, and you could, just based on the simple description, know, oh, I'm in a peat swamp forest, I'm in a montane forest, whatever. These are really quite different. So in each of these 7 forest types, 4 times a month, we just walk standardized census routes and measure the population density of many different animals in them, but I'm going to focus today on gibbons. And in those areas that are indicated in red there are 120 plots across this landscape where every month we measure the productivity of the trees. So we have about 15,000 trees that are tagged that we every month go and visit and write down, is it reproducing or not. So we're, you might say, a little obsessed with understanding these really simple things about the ecological environment. So here are the results that I found from one kind of comparison across this mosaic of 7 very different forest types. And this focuses on gibbons, which are one of the 2 species, along with leaf monkeys, that I kind of focus my research on. Now, these are just simple depictions of it. And if you look on the far left, there are 7 points on that graph. All 3 of those graphs plot altitude, so as you move from left to right, you're going up the hill. So on the far left, that shows each of those 7 forest types, what is the population density of gibbons in them. As you go up a mountain, gibbons become thinner on the ground. They become rarer. The other 2 measures are other kind of measures about the quality of an environment for a gibbon. In the middle, that's a simple index of basically how much food is available for them in that particular forest. On the right is a measure of the size of the groups. You can see all of these lines show a really clear trajectory with altitude. As you go up the hill, there's less food, groups become smaller, and the populations are much less dense. Now, I've been advised in the past not to do math in public, so I won't show you the kind of mathematical model, but I'll just simply tell you that I did a pretty basic demographic model of the kind of thing that actuaries do and all the time, and plugged into that model basic information about birth rates and death rates, etc. And based on that model, it was really quite clear that these forests up on top of the mountains cannot actually sustain gibbons. Those populations are declining. And the only reason that gibbons are found there is because they're being overproduced in the lowland forests, and they move up. The lowland forests are sources, the montane forests are sinks. So why is this important for conservation? Well, it turns out that we're, as you might not be surprised to learn, selectively losing the lowland forests in Borneo as everywhere else. We're selectively losing source forest. This is a picture from a figure that was in the journal Nature not so very long ago. The red is the creeping deforestation around our national park from 1998 to 2002, and most of that forest that's being lost is the lowland forest. Now, as conservationists, when we sit down and we try and prioritize different areas for allocation of conservation funds, or we try and calculate how many gibbons might there be left in this national park, we will take a measure of the kind of population density of our species that we measured, usually in our highest quality habitats. So that's going to give us unrealistically optimistic impressions of how many animals are actually found in these parks that we're looking at. And we know from a conservation biology perspective, the single biggest predictor of whether a particular population is able to persist or not is its size. So this is giving us dangerously optimistic pictures about how many animals are actually in these different forests. So this is a real worry. I gave a talk at a zoo a few years ago, and the title of it was, is the conservation situation for Bornean rainforest primates as bad as it seems? And the answer was no, it's worse. And this is the reason, because we're not just losing forests at alarming rates, we're losing the most important forests first. Here's just an example of the same thing. This is Gunung Lusur National Park, which is in northern Sumatra. This is the vast majority of the remaining about 3,000 Sumatran orangutans in the world are found in this national park. And that shows forest cover in 2002 projected into 2010. Again, this was a projection that was done a couple of years ago, and it's certainly come true. So we've lost again the lowland high-quality source forests. So the conservation implications of that are really quite clear, I think. But there's a second kind of perhaps less obvious risk to this sort of population dynamics that we see in these sort of very diverse environments. The vast majority of people do research on animals in source forests, in high-quality forests, and it's really quite reasonable that they do that. You're going out to do your 2-year Ph.D. study on orangutans or on gibbons. You want to go to the place where there's lots of gibbons around and you can collect lots of data. So most of the information we have about species are in the forests in which they're doing the best. Now I would suggest to you that that creates a second kind of risk, because we base an awful lot of our conservation management decisions on these mathematical models that I mentioned before. And these mathematical models are informed by really basic data that we collect in the wild about reproductive rates, life history, that sort of thing. And I would argue that most of the places that we collect those data are biased samples. These are places that have unusually high reproductive rates, unusually high population densities, and more food availability than we usually find in the average forest. So these models that we use in order to make conservation decisions are already overly optimistic because we're using data from the best places. So this is a second kind of problem related to these source sink population dynamics that I don't think is as immediately apparent, but I think is equally important from a long-term conservation planning perspective. So the implications of this final of these 3 studies that I mentioned are threefold, I think. The first is that it's really important to preserve this full complement of habitats that a particular species inhabits. For most species, we don't know how important different habitat types are. Most species haven't been studied as intensively with as much detail, perhaps as anally, as we study the gibbons at Gunung Palem. And until we know that kind of detail about populations, we really want to preserve the full complement of areas that they inhabit, because we might otherwise be removing their source forests without knowing it. The second implication, which will annoy some conservation organizations, which make a living out of doing these rapid ecological assessments, is that rapid surveys might be misleading. If you're dropped out of a helicopter onto the top of Gunung Palem, you would say, there are gibbons there. But it turns out that it's actually not gibbon habitat. The only reason there are gibbons there at all is that they're going there from the lowlands, essentially to die. Incidentally, this can actually work in the opposite direction, too. So there may be forests that animals are not in. You go out and do a really rapid survey for 2 weeks, 3 weeks, and you see no orangutans in a particular forest. Well, it may be that they don't use that forest 75, 80, 90% of the time, but in that very rare, crucial period of very low food availability, there might be special kinds of food in that particular forest that the animals go there in order to sustain themselves. So areas that may only be occupied a very small portion of the time could actually be crucial for a species' longevity. And we can think about this too from the perspective of migratory species. Species overwinter, perhaps down in the tropics, but 90% or 50% of the time, 60% of the time, that species isn't there. So unless you knew that that species came in during certain periods, you would say, this isn't a particularly important area for protecting monarch butterflies or whatever you're interested in, let's just cut it down. So these rapid surveys can be quite misleading in either direction. And finally, for the reasons I just mentioned, we should be really careful about using data that we collect in very good places in order to predict what happens in most places. Because we probably have selected the very places we work because they are good. So the answer to that third question is that forests do differ in important ways, and they're important for the species that we're interested in conserving. And if we ignore that, we're in danger of making real serious mistakes. So I want to summarize just the kind of 3 take-home results I think come from these studies that I've been doing in Borneo. The first is simply that degraded forests can retain high conservation value. This is often not recognized, but I would suggest it needs to be more importantly considered. The second is some, but not all, species can survive and reproduce in these degraded habitats. And we might be able to identify the species that won't and target them for special protection based on perhaps a little prick of their blood to figure out how old that species is. And finally, species can occupy habitats that can't actually support them. So you can go somewhere, see organisms in a place, but that place might not actually be able to sustain them if you remove the things that are contiguous with it. So I think this is just sort of 3 fairly simple examples of how I think a scientific and an explicitly evolutionary and indeed Darwinian approach has provided some results that could really meaningfully inform our conservation of Borneo's critters. And I'm going to stop there and thank you for your attention.
Okay, we're going to have some questions. I don't know if there's a mic set up for folks or not in the front. Okay, might have that in a moment.
Yeah, did you correlate a decrease in population of the orangutans with the increase in population of humans?
So the question was, did we correlate the decrease in orangutan? I guess I could use this. Did we look at the effects of human population density on orangutans? And I tried to do that, and I've done larger analyses across Borneo that actually show that's very much the case. In that particular study, it was difficult to know how exactly we would calculate that because it's a bunch of villages that are dispersed across the environment, and the orangutans are kind of laid in a mosaic over that area. So it's a little bit difficult to know how you would characterize a particular area in terms of population density that would reflect the human sort of impacts on the populations that were around that. But these kinds of studies have been done in Africa, for example, where you can look at the areas where forests are being lost, and that correlates almost perfectly, as you would anticipate, with human population increases. To the point where we currently don't include any indices about human population density in those, the IUCN Red List, the criteria that actually determine whether species should be endangered or critically endangered. And some people have argued that in cases when we don't know very much about a species or don't know very much about its distribution, just knowing the rate at which human populations in those areas are growing tells us quite a bit about the risk as it is. So your intuition is right. That must be really quite important. I didn't actually get at that in that particular study, but clearly that's the underlying factor. The more people that are in these areas, the more hunting that goes on, the faster rates forests are cleared, etc. Yeah.
Do you think there are realistic ways to preserve the necessary habitats, yet still supply various civilizations with the resources that we've come to rely on?
So the question was the simple question of, are there ways to protect forests while still providing the resources that are needed for human populations? I wish I could tell you yes. That's the fundamental issue, of course. There are some intriguing indices. There are indications that in some places people have made this work. For example, if we're worried about orangutans, we know that these moderately logged forests actually can house orangutans just fine. So if you can have a local community managing a patch of forest, removing the very high value timber species, but basically doing minimal impact otherwise, they can get enough income from those particular species in order to make a living and not cut down the rest of the forest. Now, I don't want to argue that that's a panacea. I mean, there are some cases in which that works, and there are many cases where people have tried this where it doesn't work. You need an awful lot of things in place in order for that to happen. Local communities need to have actual control of their resources, and logging bosses from outside can't be coming in and stealing their timber, etc., etc. I mean, there's lots of different kinds of factors that can work, but this is one way that sort of we as people in the West can have an impact. Because those kinds of logging operations can get certified by organizations like Smartwood, the Forest Stewardship Council. Actually, if you go to Home Depot now, you can see some wood that's got stamps on it, FSC certified. And it's kind of the equivalent of dolphin-safe tuna, right? This is these are trees that have been harvested in forests that are sustainable for animals that live in them. So we actually can, if we support the people that are doing it right, as consumers, we actually have quite a bit of power. And in contrast, when we support the people that aren't, we're positively giving incentives to people that aren't. Now, I'm not suggesting that it's easy. I mean, if it were easy, we wouldn't be worrying about it anymore. We really need a host of different approaches in many different areas. But there are some indications that this can work in some areas. And really, the most important thing is to ask the local people what they need and what it would take. Because often you have people coming in and just trying to impose some conservation model without really engaging the local communities, and lo and behold, it doesn't work.
Okay, if you have questions, we have a microphone over here on the side, so you can come down here, that way we can hear the question.
Thanks very much for being here. In the 1880s in Brazil, the Atlantic rainforest was started to be reforested by the king of Brazil at the time. Some of the problems with that were species that were brought in from other areas brought in there. That doesn't relate to your area. What does relate to your area? Has anyone given any thoughts to doing any reforestation? And one of the good things in Brazil was that they also planted the underbrush as well as just the trees. Unlike Americans, they go through and plant trees and that's all you see.
So there's, I guess I have two kinds of responses to that. The first is that reforestation, restoration is really important, but it's a very inefficient way to do conservation. We would be I would argue, much better served to use the resources we have at the moment to protect the remaining forests that are standing from being cut down. Because it's really complicated to try and regrow a tropical forest. For a number of reasons. The first of which is, most people don't realize the soils in tropical forests are terrible. It's so humid there, the temperatures are so high that things decompose immediately and the root system immediately sucks up all those nutrients. So the soil never builds up, which is why when McDonald's used to clear the rainforest, grow grass for cattle after 2 or 3 years, you couldn't grow anything on it anymore because the soil was incredibly poor. So it's a bit paradoxical. We assume that rainforests have great soils, but they actually don't. So that's one of the things that makes it difficult to regrow a forest, and why I would, from my bucks, try and focus on areas that are still standing. Now that said, of course, there are huge swaths of areas that aren't still standing that we want to still improve, and there have been really substantial efforts to do reforestation. In fact, one of the bigger areas in the ecology group at Davis that I'm in is the field of restoration ecology, and people are very interested in these kinds of things. It turns out, as I think your question indicates that you already know, it's not very easy to do this, because the tropical hardwoods that we really want to come back are things that don't grow in direct sunlight, so we need to grow something else up first so that they can grow underneath them. Most tropical trees that are those large canopy trees are not all of them, but many of them, certainly in Asia, are not dispersed by wind, they're dispersed by animals that eat the fruits and then travel and defecate the seeds. So you can't sort of shoot a monkey out of a catapult and have it fly over and defecate on its way by. Right? There's no good way to sort of bring these seeds into these areas. It would be fun. It would be fun. I can't even get my serious grants funded, so I'm going to try that.
We're going to have one more question. If you have any questions, Dr. Marshall will be around and will be able to talk to you directly, so that would be you. Yeah.
Given your experiences and your conclusions, what conservation groups do you think are most worthy of our donations?
Great question. Well, one thing that I've learned is that most people know about these big international NGOs, the Nature Conservancy, Conservation International, WWF, that kind of thing. Many of those programs do really good work. but they're highly, highly variable based on the country that they're running and also based on the specific projects that they're doing. Also, those large conservation organizations sometimes have fairly large overhead in terms of the money that goes into sustaining their massive fundraising edifices, among other things. So if you know a particular project that the Nature Conservancy or Conservation International is doing, and you think it's good, I would give money that's earmarked, allocated solely for that particular program. And you can do that in most of these programs. Small NGOs can be great bang for your buck. But with lots of these things, it's all about doing some research and figuring out what exactly they're doing. But even simple things you can look up online, like what percentage of their money goes into overhead. That's a really important thing. Conservation organizations are just now starting to really try and quantitatively measure the effects of what they're doing. And so some of that information is coming out. You can actually look and see what is the change in forested area in this particular area that this group has been working in for some amount of time. So it's a little bit of a cop-out for me to say, go and look for yourself, but there's lots of groups are doing lots of really good work, and I've worked with a bunch of them, and I've just seen within these organizations there's quite a bit of variation. Even within the Conservation International Indonesia program, for example, some programs are really well run, and some don't work as well. So it's the more targeted you can be, I think the more effective you'll be.
We'll thank our speaker again, and also as a token of our appreciation for coming out here, particularly on Super Bowl Sunday. We have a gift basket for our speaker. I'm not sure if there's massage oils in there, but who knows? And since, of course, it is Charles Darwin's birthday, we're a week early. We have his cake. Some of you have been cutting into it in the last couple minutes, so please feel free, mingle, have some food. That's what it's all about. And thank you very much for coming.
We haven't sung.
Oh yes, I almost forgot. We have to sing Happy Birthday, Charlie.
That's what I want to do.
Me? Birthday to you. Happy birthday to you. Happy birthday, dear Charlie. Happy birthday to you. And thank you all again for coming.
Believe in me, that's okay. Really, I'm not that vain. Besides, this isn't about them.